Hey guys, this is Space Train, your daily express till the edge of the space, and today we will talk about how much would you weigh on other planets. Grab your tickets and let's go. Don't forget to subscribe to get unlimited pass on our expedition. Alright, it's time to dip our toes into the wonderful world of science and explore the difference between mass and weight. Most of you already use these two words on an almost daily basis, especially if, like me, you're conscious of your weight and spend hours agonizing over how much muscle mass you built during your last visit to the gym. But do you really know the difference between weight and mass? We often use the words mass and weight interchangeably, but they mean quite different things. Your mass is the same no matter where you go in the universe. Your weight, on the other hand, changes from place to place. Mass is measured in kilograms, even though we usually talk about weight in kilograms. Strictly speaking, it should be measured in newtons, the units of force. Mass is a measurement of an object's tendency to resist changing its state of motion, known as inertia. Left to its own devices, an object will stay put or move in a straight line. Think of a puck on an air hockey table. Unless some force, like friction, or banging into a wall, acts on the puck, it will keep sliding on the same path forever. Mass is a measure of how much force it will take to change that path. Mass depends on how much matter, atoms and so on, there is in an object. More mass means more inertia, as there is more to get moving. This is Isaac Newton's idea of mass, which underpins his famous laws of motion developed in the late 1600s. It is not quite accurate at extremely high speeds, where Albert Einstein's 20th century theory of special relativity is required, but it's fine for most everyday situations. If you want to find out more about relativity, check our other video. Link is down below. Weight, on the other hand, is a measure of the amount of downwards force that gravity exerts on an object. This force increases with the object's mass. The more inertia it has, the harder gravity pulls. On Earth's surface, the force of gravity is about 9.8 newtons per kilogram. Formula: weight equals mass multiplied by gravitational acceleration. W equals mg. Simple, right? It's only because we are used to dealing with conditions on the surface of Earth. When we say someone weighs 70 kilos, we really mean their mass. Their weight would be 70 times 9.8 equals 686 newtons. This force, 686 newtons, is actually what bathroom scales are measuring. They convert it into kilograms for convenience. Even on the International Space Station, where astronauts are weightless, they still have mass. They must still exert force to push themselves off the walls or pull themselves along, and the bigger they are, the more force it will take. Mass can never be zero. What we mean by this is that everything in the universe has mass. If it didn't, it simply wouldn't exist. Unlike mass, weight can be zero. An example of this is an astronaut floating in space. There's no gravity acting on his body and, therefore, he has no weight. So a trip to space might be a quick way to lose weight, but losing mass is another matter. We will explore this difference a little further, and let's see how much would you weigh on other planets. We already learned that our mass is the amount of matter that we consist of. This mass does not change when we change planets. However, if we went from Earth to Mars, our weight would change because Mars has less gravity than Earth. Gravity is a force pulling matter together. We talk about this in our latest video, you can check link down below. Earth's gravity wants to keep everything pulled toward the center of the planet, keeping us from falling off the Earth. Every object in space has gravity. Stars, moons, and planets all have gravity. The amount of gravity they have depends on their size. So, a small planet has less and larger planet has more gravity. Just like the planets, a person with more mass has more gravity and therefore weighs more. When we measured how much does 70 kilogram mass weigh on Earth, we get 686 newtons. But on the Moon, a 70 kilogram astronaut would weigh only 112 newtons. This is about what an 11.5 kilogram object would weigh on Earth. When astronauts visited the Moon, which has only a sixth of our gravity, they bounced around on the surface as if they were floating with each step. If you decide, find a new home outside the Earth, down below you can find some links that will help you calculate your weight on other planets. When you check, don't forget to tell us which is the best planet for you. There are lots of questions left, so don't space out, and leave some space in your brain. I hope you enjoyed this video. If you want to see more, subscribe and click the bell button to get notifications on our latest videos. If you are still here, grab your knowledge and get out of my train.